All right, here we go. To talk about quadratics, you need to talk about parabolas. And there's several different ways you can write the equations for them. First way, if I give you the special spot on a quadratic, it's the vertex. Okay, then that spot is 4 comma negative 1. You should be able to write me a form of the equation based on that. Write me an equation that uses 4 comma 1 as the vertex. Starts with y equals. Okay, if you haven't got it yet, you probably weren't going to get it. X, and then this is minus 4, and this is minus 1. Raise your hand if you knew that. Okay, good. That is the vertex form. What about general form? Well, generally, you can just do what? Multiply it out. Go ahead and multiply that thing out. In case you've forgotten, you got to go like this. And you do have to do that multiply first, and then the last thing you do is add in the negative 1 at the end. Plus 16 and the minus 1 makes what? Plus 15. All right, now, I want you to look at this graph for a second here and see, does it look to you like these are important spots on the graph? There's 4 names for them. Write them down. If you remember the 4 names for those things. At least you ought to remember 2 or 3 of the names. There are 4 names for these spots right here. Okay, DD, give me 2 of the names.
Solution.
Yep. That's all you got? Holy cow.
I said where x equals 0 or x intercepts.
There you go. X-intercepts. X-intercepts and solutions. You got 2 of them. You got the other 2?
Zeros.
Zeros and the roots. All right, good job. Awesome. Zeros, roots, solutions, x-intercepts. Those are the 4 things that these are. Now, next thing. You can write this in factored form. This isn't factored form. That's vertex form. This isn't factored form. That's general form. Factored form looks like this. And it kind of looks like this, but then it couldn't have like a minus 1 out there. So try to write this in factored form, as in factor it. Yes, you can. All right, I'm going to say equals 0, or we could have said equals y. And you have an x and an x. And then what multiplies to make 15? 3 and 5. 5 and 3. And they both negative or both positive? Negatives. All right, now, I know most of you did that by factoring this right here, which is a good way to do it. But there's another way. You could have looked here and said, the answer is 3, so I need this to be x minus 3. The answer is 5, so I need this to be x minus 5. See how that's easier? Yeah. Okay. Next, what if I had given you a parabola that was like over here, and all I told you was that it touched here and it touched there? How could you figure out, if I knew that it generally went like this, how could you figure out where its vertex was? Yeah, figure out the center. What's right in the middle of these two? Well, this is at negative 3, 4, 5, 6, 7. This is at negative 8. What's the average of negative 3 and negative 8? Because it's negative 11 total. So it's going to be a nasty decimal. Let's not do that to you. That makes it too complicated. Let's go negative 3, and let's go 4, 5, 6, 7, 8, negative 9. That'd make it easier. So then what's exactly between those two? Okay, that's called the something of something. Axis of symmetry. X equals negative 6. All right, so that line's important. It tells me that the vertex is somewhere around there. I'm not sure. Maybe it's lower. But I know it's on that line somewhere. Maybe it's up here. Maybe it's way down here. But I know it's negative 6 comma something. How do I figure out the something? Put it in the equation. Do I have the equation? No. I could make the equation, though. How could I make the equation? Somebody just said it. Yeah, because this one right here tells me x plus 9, and this one right here tells me the other factor would be x plus 3. So there's my equation for it. And now I just got to stick in a negative 6 into this. And that makes negative 3 and positive 3, negative 9. So this would have to be a negative 9. Do you get how I got that point? I stuck this into this equation. All right. That kind of sums up everything that you needed to know, other than hardcore factoring, like you were doing last night. You were doing things like this. Okay. I think that's probably because it used words. Like, that is called a difference of what? Squares. So they said make up your own difference of squares. Well, I just made up my own difference of squares. Just wait. You can make your own up. It's really easy. Change it to a 16x to the fourth minus 144. Those are both perfect squares. Because see, when I do these, I just have to go, okay, what's the square root of this? What's the square root of that? So I have 2x and 2x. What's the square root of that? Can't do that. Has to be a perfect square, right? All right, so if we take a 4 out of it, then we'll have 4 going into both of them. Means you got 4 times x squared minus 8. Is that a perfect square? Nope. So then you'd be done. You have factored it as far as you can. But most of the time, this will be like 36. And then when you take a 4 out, it'll be x squared minus 9. Now it is, because I just changed this to a perfect square and that to a perfect square. But you're right. And that's the thing you got to look out for. There's 2 ways that people get these wrong. If this isn't a perfect square, like it wasn't, or if this isn't a minus, because if it's a plus, then you have to do this fancy thing. Yes? Okay, you were going to give an answer? Just generally airing your hand out? Okay. Yes?
So to make a like x squared minus 25.
Yep. That's the difference of squares. Because they're both perfect squares. That's a perfect square, and that's a perfect square. And then you just do a plus and a minus. Okay, so this is a difference of squares, and this is the factored form for it. All right. No, it doesn't matter which one of these is plus and which one's minus. They're identical other than that, so you can switch those around. But it has to be a minus, otherwise it's not a difference of squares. Okay, the next thing they talk about is one where a is not equal to 1. Well, here's a normal one. X squared plus 3x plus 2. That one, the a term, which is the number right in front here, is 1. So all I was saying is find one where this would be something not 1, like 2. But you want it to actually work. So what you do to like make one that will work is you say 2x and x, and you like try to figure out, multiply one out. Say this is plus 1 and this is minus 3. If you actually multiply this thing out, I want you to do that right now. Practice your FOIL. Then it'll tell you a question that could have been factored. See, I'm starting with the answer, and now I can make a question. When you're done, actually write it on paper. 2x squared. This is negative 6. This is positive 1 minus 5x. Lasts make negative 3. So there's one where a is not equal to 1. What is a equal to in this one? 2. That's the a term. So that's an example of a problem where a is not equal to 1. They could, but they wouldn't. But they could. If they asked you for a difference of squares where a was not equal to 1, here is a difference of squares. And now I have to put a number up in front that would actually make this bigger than 1 for a. Then I could put a 2 here, but if I times this by 2, I got to times that by 2. And that'd be 2x minus 32. Now I've made a difference of squares where a is not equal to 1. And then I can factor out the 2 first. Actually, I should do this. 2 comes out first, and I get x squared minus 16, and then I can go 2, parenthesis, parenthesis, x plus 4 minus 4. All right. A lot of good questions. I'd say one of the biggest problems people have is multiplying out big ones like this. What form is that in? Vertex form. And people will do it in the wrong order. First of all, some people, the weak-minded, will say that is x squared plus 9. It's not. You would instead want to do this. And really, what does that come out to be? X squared plus 6x plus 9. Then, after you got that part done, you want to times everything by 2. All of this stuff. 2x squared plus 12x plus 9 times 2 is 18. Then, at the very end, you slap on the minus 5. And then that can be put with the 18. Final answer, 2x squared plus 12x plus 13. That is the answer to that, except I forgot my y. And that's in what form? General form. So it's got an A and a B and a C in it. Where's the y-intercept in that puppy? Yep. The y-intercept is where x is 0, so that would be gone and that would be gone. Can you just tell where the y-intercept is looking at this form? No, because if x is 0, this becomes 0, and it doesn't like cancel things. 0 plus 3 is 3, and then you can't figure it out super easy. You can. I mean, it just isn't sitting there. So to get the y-intercept, x is 0, so I stick a 0 in here, and this will be 3. 3 squared is 9. 9 times 2 is 18. 18 minus 5 would be 13. So 13 is the y-intercept, and there it is. If I just had the other form of the equation, it would be easier to see. Okay. So there's a bunch of stuff that you needed to know. One other thing that I want to remind you about is, I guess I did remind you, but if you have one where you have to find this dotted line down the middle, that's called the what of what? Axis of symmetry. And then if then you know that this is like x equals negative 6, how do I figure out where this vertex point is? You plug this back into the formula. That's right. Or into the equation. One other thing people asked a lot about the other day was if they say alpha of 7, what did they tell you by doing that? That x is 7. And then they want to know what y is. Okay, I think that's enough review. So now we're going to take a little homework quiz. And I'm also going to hand out your... I'm also going to hand out your worksheet. Yes, we were taking it through Sentia. All right, so I'm going to hit